from Innovation Crossroads. We have Don DeRosa. Don's going to explain how Eonix is developing a revolutionary approach to discovering next-generation electrolyte chemistries to create a novel new battery and energy storage materials. Take it away, Don.
Thanks, John. Good evening, everybody. I'm DeRosa. I'm the CTO of Eonix, and we're rapidly designing electrolytes to improve energy storage for a greener future. Oh, I think we're skipping past. All right. So from 1989 to today, we've generated half of all greenhouse gases in human history. The need to sever our consumption of fossil fuels has never been more prevalent. And thankfully, there's been a race to adopt clean technology as a result by governments and companies alike. New York State has mandated that their entire grid will be powered by 100% renewables, and nearly every auto manufacturer is planning to electrify their entire fleet in the next 2 decades as well. Unfortunately, energy storage technology is not on their side. These slides are not on my side as well. Do you want me to just vocalize it? It's all blank, I don't know. I mean, worked before. Okay, all right, cool. Well, it's playing on repeat back there, so if you guys want to see all the images, you can. I can go through this verbally if you're cool with that, John. No? No? All right.
Improvise, adapt, overcome.
Yeah. Okay, so New York State is trying to have their entire state go 100% renewable by 2040. And energy storage systems currently are too expensive and don't have the same response time that they need to make that happen. And similarly, for automotive manufacturers to electrify their fleet, we're looking at a 65% cost of energy storage per vehicle right now. So electric vehicles just can't be made at a price point where the average consumer can buy them. So we need to attack that. So why is nobody trying to solve this problem? Well, a lot of people are. We can take a look at some of the companies that have tried to solve this problem in the past. Ioxys was developing a high power energy storage material. After a decade and over $150 million in funding, their device was too expensive. Cillian Nanotech, you might have heard them in the news. They've raised almost $250 million. It's been about 10 years and their product's still under development. Well, hopefully they'll get there. And Aquan Energy, also 10 years, raised about 200 million, and they declared bankruptcy. And they were acquired for, or the assets were acquired for 2 million later on. So essentially, it takes decades of time that we don't have these solutions. It takes hundreds of millions of dollars, and you're most likely to fail. So what we did is develop a new type of apparatus that essentially shrinks the amount of time it takes to look at one molecule from 10 months to 8 days. So that puts the odds in our favor. We're essentially, yeah, see, it was there. Yeah.
You're gonna have to tell me to.
Okay, I could just keep going. Yeah, just keep going, keep going. Sorry about this, guys. We did a demo, it worked. Here we go. So conventional like Tesla, when they look at a new chemistry, it takes them about 10 months to look at one chemistry. We developed a semi-automated system that shrinks that 10 months down to 8 days. So we can look at a compound drastically quicker. And the time it takes Tesla to look at one chemistry, we've already looked at 37. Now, how do we do this? We select a compound that already exists at scale from a chemical manufacturer. We feed it through our 3E system. So that's a system that takes 16 different measurements to understand the molecule very well. The data is automatically processed by an AWS-powered script, which generates a results report recommending how we need to change that molecule to make the system better. And we do this as an experiment, and this is not computational. So we build the actual devices. We get the results in 8 days, and for substantially reduced costs. So this only costs us $3,000 to look at one molecule instead of maybe $500,000. So in the, so we currently have devices, is it? Okay. Since our system came online in 2018, we've looked at 44 different chemistries, whereas I like to think fast-forwarded past 35 years worth of research. We have devices that store 22% more energy today at a 10% lower cost. And we're projected to have devices next year with a commercial product launch that is an electrolyte that allows these devices to store 68% more energy and reduce system cost by 20%. And I want to remind you, this is just the electrolyte. So existing factories can use this material integrated into their system and just instantly see an upgrade. So it's not as capital intensive as other energy storage technologies. Looking forward, we're going to leverage the system to design non-flammable lithium-ion battery electrolytes, and also electrolytes that can enable energy-dense silicon electrodes. So we can use the same apparatus to build out product lines for these fields as well. We're looking for collaborators, partners. Just come by our booth and talk to me. Thank you for your time.
Thanks, Don. So.